So, okay, great. We talked about OpenCog, which is kind of the software framework, but also the actual attempt to build an AGI system. And then there is this exciting idea of SingularityNet. So maybe can you say first, what is SingularityNet?
Sure, sure. SingularityNet is a platform for realizing a decentralized network of artificial intelligences. So Marvin Minsky, the AI pioneer who I knew a little bit, he had the idea of a society of minds. Like you should achieve an AI not by writing one algorithm or one program, but you should put a bunch of different AIs out there, and the different AIs will interact with each other, each playing their own role, and then the totality of the society of AIs would be the thing that displayed the human level intelligence. And I had, when he was alive, I had many debates with Marvin about this idea, and I think he really thought the mind was more like a society than I do. Like I think you could have a mind that was as disorganized as a human society, but I think a human-like mind has a bit more central control than that. Actually, like I mean, we have this thalamus and the medulla and limbic system. We have a sort of top-down control system that guides much of what we do, more so than a society does. So I think he stretched that metaphor a little too far, but I also think there's something interesting there. And so in the 90s, when I started my first sort of non-academic AI project, WebMind, which was an AI startup in New York in the Silicon Alley area in the late 90s, what I was aiming to do there was make a distributed society of AIs, the different parts of which would live on different computers all around the world, and each one would do its own thinking about the data local to it. But they would all share information with each other and outsource work with each other and cooperate, and the intelligence would be in the whole collective. And I organized a conference together with Francis Heiligen at Free University of Brussels in 2001, which was the Global Brain Zero conference. And we're planning the next version, the Global Brain One conference, at the Free University of Brussels for next year, 2021. Awesome. So 20 years after. And then maybe we can have the next one 10 years after that, like exponentially faster until the singularity comes, right?
The timing is right. Yeah.
yeah, exactly. So the idea with the global brain was, maybe the AI won't just be in a program on one guy's computer, but the AI will be, in the internet as a whole, with the cooperation of different AI modules living in different places. So one of the issues you face when architecting a system like that is, how is the whole thing controlled? Do you have like a centralized control unit that pulls the puppet strings of all the different modules there? Or do you have a fundamentally decentralized network where the society of AIs is controlled in some democratic and self-organized way by all the AIs in that society, right? And Francis and I had a different view of many things, but we both wanted to make like a global society of AI minds with a decentralized organizational mode. Now, the main difference was he wanted the individual AIs to be all incredibly simple and all the intelligence to be on the collective level. Whereas I thought that was cool, but I thought a more practical way to do it might be if some of the agents in the society of minds were fairly generally intelligent on their own. So like you could have a bunch of OpenCogs out there and a bunch of simpler learning systems. And then these are all cooperating and coordinating together, sort of like in the brain. Okay, the brain as a whole is the general intelligence, but some parts of the cortex, you could say, have a fair bit of general intelligence on their own, whereas, say, parts of the cerebellum or limbic system have very little general intelligence on their own, and they're contributing to general intelligence, by way of their connectivity to other modules.
Do you see instantiations of the same kind of, maybe different versions of OpenCog, but also just the same version of OpenCog and maybe many instantiations
Yeah,
of
yeah.
it as being all
Exactly.
part of
That's
the
what
network,
David and Hans and I want to do with many Sophia and other robots.
right?
Yeah, yeah. Each one has its own individual mind living on a server, but there's also a collective intelligence infusing them and a part of the mind living on the edge in each robot, right?
Yeah.
So the thing is, at that time, as well as WebMind being implemented in Java 1.1 as like a massive distributed system,
Yeah.
their blockchain wasn't there yet. So how them do this decentralized control? We sort of knew it. We knew about distributed systems. We knew about encryption. So I mean, we had the key principles of what underlies blockchain now, but I mean, we didn't put it together in the way that's been done now. So when Vitalik Buterin and colleagues came out with Ethereum blockchain, many years later, like 2013 or something, then I was like, well, this is interesting. Like this is Solidity scripting language. It's kind of dorky in a way, and I don't see why you need a Turing complete language for this purpose. But on the other hand, this is like the first time I could sit down and start to like script infrastructure for decentralized control of the AIs in a society of minds in a tractable way. Like you could hack the Bitcoin code base, but it's really annoying. Whereas Solidity is Ethereum scripting language is just nicer and easier to use. I'm very annoyed with it by this point, but like Java, I mean, these languages are amazing when they first come out. So then I came up with the idea that turned into SingularityNET. Okay, let's make a decentralized agent system where a bunch of different AIs, wrapped up in say different Docker containers or LXC containers, different AIs can each of them have their own identity on the blockchain, and the coordination of this community of AIs has no central controller, no dictator, right? And there's no central repository of information. The coordination of the society of minds is done entirely by the decentralized network in a decentralized way by the algorithms, right? Because the motto of Bitcoin is in math we trust, right? And so that's what you need. You need the society of minds to trust only in math, not trust only in one centralized server.
So the AI systems themselves are outside of the blockchain, but then the communication
at the
between them.
moment, I would have loved to put the AI's operations on chain in some sense, but in Ethereum it's just too slow. You can't do it.
Somehow, it's the basic communication between AI systems that's
So
that's the distributed.
Basically, an AI is just some software in Singularity. An AI is just some software process living in a container. And
there's input and output.
There's a proxy that lives in that container along with the AI that handles the interaction with the rest of SingularityNet. And then when one AI wants to contribute with another one in the network, they set up a number of channels. And the setup of those channels uses the Ethereum blockchain.
Got it.
But once the channels are set up, then data flows along those channels without having to be on the blockchain. All that goes on the blockchain is the fact that some data went along that channel. So you can do.
So there's not a shared knowledge. It's
the identity of each agent is on the blockchain,
right,
on the Ethereum blockchain. If one agent rates the reputation of another agent, that goes on the blockchain. And agents can publish what APIs they will fulfill on the blockchain. But the actual data for AI and the results from AI is not on the blockchain.
Do you think it could be? Do you think it should be?
In some cases it should be. In some cases, maybe it shouldn't be. But I think that.
So I'll give you an example.
Using Ethereum, you can't do it. Now, there's more modern and faster blockchains where you could start to do that in some cases. 2 years ago, that was less so. It's a very rapidly evolving ecosystem.
So, like one example, maybe you can comment on. Something I worked on a lot on is autonomous vehicles. Yeah. You can see each individual vehicle as a AI system, and you can see vehicles from Tesla, for example, and then Ford and GM and all these as also like larger. I mean, they all are running the same kind of system on each sets of vehicles. So it's individual AI systems on individual vehicles, but it's all different stations, the same AI system within the same company. So, you can envision a situation where all of those AI systems are put on SingularityNet, right?
Yeah.
And how do you see that happening, and what would be the benefit, and could they share data? I guess
Yeah,
one of the
yeah.
biggest things is that the power there's in a decentralized control, but the benefit would have been is really nice if they can somehow share the knowledge in an open way if they choose to.
Yeah. Those are all quite good points. So I think the benefit from being on the decentralized network, as we envision it, is that we want the AIs in the network to be outsourcing work to each other and making API calls to each other frequently.
Okay, I got you.
So the real benefit would be if that AI wanted to outsource some cognitive processing or data processing or data pre-processing, whatever, to some other AIs in the network which specialize in something different. And this really requires a different way of thinking about AI software development, right? So just like object-oriented programming was different than imperative programming, and now object-oriented programmers all use these frameworks to do things rather than just libraries even. Shifting to agent-based programming, where your AI agent is asking other like live, real-time evolving agents for feedback in what they're doing. That's a different way of thinking. I mean, it's not a new one. There was loads of papers on agent-based programming in the 80s and onward. But if you're willing to shift to an agent-based model of development, then you can put less and less in your AI and rely more and more on interactive calls to other AIs running in the network. And of course, that's not fully manifested yet, because although we've rolled out a nice working version of SingularityNET platform, there's only 50 to 100 AIs running in there now. There's not tens of thousands of AIs. So we don't have the critical mass for the whole society of mind to be doing what we want.
The magic really happens when there's just a huge number of agents.
Yeah. Exactly. In terms of data, we're partnering closely with another blockchain project called Ocean Protocol. And Ocean Protocol, that's the project of Trent McConaughey, who developed Big Chain DB, which is a blockchain-based database. So Ocean Protocol is basically blockchain-based big data and aims at making it efficient for different AI processes or statistical processes or whatever to share large data sets, or one process can send a clone of itself to work on the other guy's data set and send results back and so forth. So by getting Ocean and you have data lake, so this is the data ocean, right? So by getting Ocean and SingularityNET to interoperate, we're aiming to take into account of the big data aspect also. But it's quite challenging, because to build this whole decentralized blockchain-based infrastructure, I mean, your competitors are like Google, Microsoft, Alibaba, and Amazon, which have so much money to put behind their centralized infrastructures. Plus, they're solving simpler algorithmic problems, because making it centralized in some ways is easier, right? So they're very major computer science challenges. And I think what you saw with the whole ICO boom in the blockchain and cryptocurrency world is a lot of young hackers who are hacking Bitcoin or Ethereum, and they see, well, why don't we make this decentralized on blockchain? Then after they raise some money through an ICO, they realize how hard it is. It's like actually we're wrestling with incredibly hard computer science and software engineering and distributed systems problems, which can be solved, but they're just very difficult to solve. And in some cases, the individuals who started those projects were not well equipped to actually solve the problems that they wanted.
So you think? Would you say that's the main bottleneck? If you look at the future of currency, the question is, well,
currency, the main bottleneck is politics. Like, it's governments and the bands of armed thugs that will shoot you if you bypass their currency restrictions.
That's right. So, like, your sense is that versus the technical challenges, because you kind of just suggested the technical challenges are quite high as well.
I mean, for making a distributed money, you could do that on Algorand right now. I mean, so that while Ethereum is too slow, there's Algorand and there's a few other more modern, more scalable blockchains that would work fine for a decentralized global currency.
Right.
So I think there were technical bottlenecks to that 2 years ago, and maybe Ethereum 2.0 will be as fast as Algorand. Right. I don't know. That's not fully written yet, right? So I think the obstacle to currency being put on the blockchain is that,
Is the other
I
stuff
mean,
you mentioned.
currency will be on the blockchain. It'll just be on the blockchain in a way that enforces centralized control and government hegemony rather than otherwise. Like the ERMB will probably be the first currency on the blockchain. The e-ruble may be next. They're already working.
E-ruble.
Yeah. I mean, the point
Oh,
is
that's hilarious.
digital currency, makes total sense, but they would rather do it in the way that Putin and Xi Jinping have access to the global keys for everything, right? And
So, and then the analogy to that in terms of SingularityNET, I mean, there's echoes. I think you've mentioned before that Linux gives you hope. And
AI is not as heavily regulated as money, right?
Not yet, right? Not yet.
Oh, that's a lot slipperier than money too, right? I mean, money is easier to regulate because it's kind of easier to define, whereas AI it's almost everywhere inside everything. Where's the boundary between AI and software, right? I mean, if you're going to regulate AI, there's no IQ test for every hardware device that has a learning algorithm. You're going to be putting like hegemonic regulation on all software, and I don't rule out that
And
could
the
happen.
adaptive software.
And but how do you tell if software is adaptive? And every software is going to be adaptive. I mean,
well, maybe 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 we're living in the golden age of open source that will not always be open. Maybe it'll become centralized control of software by governments.
It is entirely possible, and part of what I think we're doing with things like SingularityNET protocol is creating a tool set that can be used to counteract that sort of thing. Say a similar thing about mesh networking, right? Plays a minor role now, the ability to access internet like directly phone to phone. On the other hand, if your government starts trying to control your use of the internet, suddenly having mesh networking there can be very convenient, right?
Yeah.
And so right now, something like a decentralized blockchain-based AGI framework or narrow AI framework, it's cool. It's nice to have. On the other hand, if governments start trying to tamp down on my AI interoperating with someone's AI in Russia or somewhere, right? Then suddenly having a decentralized protocol that nobody owns or controls becomes an extremely valuable part of the tool set. And we've put that out there now. It's not perfect, but it operates, and it's pretty blockchain agnostic. So we're talking to Algorand about making part of SingularityNET run on Algorand. My good friend Tufi Saliba has a cool blockchain project called Toda, which is a blockchain without a distributed ledger. It's like a whole other architecture. So there's a lot of more advanced things you can do in the blockchain world. SingularityNET could be ported and to a whole bunch of, it could be made multi-chain and ported to a whole bunch of different blockchains. And there's a lot of potential and a lot of importance to putting this kind of tool set out there. If you compare to OpenCog, what you could see is OpenCog allows tight integration of a few AI algorithms that share the same knowledge store in real time, in RAM, right? SingularityNET allows loose integration of multiple different AIs. They can share knowledge, but they're mostly not going to be sharing knowledge in RAM on the same machine. And I think what we're going to have is a network of networks, right? Like, I mean, you have the knowledge graph inside the OpenCog system, and then you have a network of machines inside a distributed OpenCog mind. But then that OpenCog will interface with other AIs doing deep neural nets or custom biology data analysis or whatever they're doing in SingularityNET, which is a looser integration of different AIs, some of which may be their own networks, right? And I think at a very loose analogy, you could see that in the human body. Like the brain has regions like cortex or hippocampus, which tightly interconnect like cortical columns within the cortex, for example. Then there's looser connection within the different lobes of the brain, and then the brain interconnects with the endocrine system and different parts of the body even more loosely. Then your body interacts even more loosely with the other people that you talk to. So you often have networks within networks within networks with progressively looser coupling as you get higher up in that hierarchy. I mean, you have that in biology, you have that in the internet as a just networking medium. And I think that's what we're going to have in the network of software processes leading to AGI.
That's a beautiful way to see the world. Again, the same similar question as with OpenCog. If somebody wanted to build an AI system and plug into the SingularityNet, what would you recommend? Like,
Yeah,
how
so
would they go about?
that's much easier. I mean, OpenCog is still a research system, so it takes some expertise and some time to. We have tutorials, but it's somewhat cognitively labor intensive to get up to speed on OpenCog. And I mean, what's one of the things we hope to change with the true AGI OpenCog 2.0 version is just make the learning curve more similar to TensorFlow or Torch or something. Because right now, OpenCog is amazingly powerful, but not simple to deal with. On the other hand, SingularityNet, as a open platform, was developed a little more with usability in mind, although the blockchain is still kind of a pain. So I mean, if you're a command line guy, there's a command line interface. It's quite easy to, take any AI that has an API and lives in a Docker container and put it online anywhere, and then it joins the global SingularityNet. And anyone who puts a request for services out into the SingularityNet, the peer-to-peer discovery mechanism will find your AI, and if it does what was asked, can then start a conversation with your AI about whether it wants to ask your AI to do something for it, how much it would cost, and so on. So that's fairly simple. If you wrote an AI and want it listed on like official SingularityNet marketplace, which is on our website, then we have a publisher portal, and then there's a KYC process to go through, because then we have some legal liability for what goes on that website. So that, in a way, that's been an education too. There's sort of two layers. Like there's the open decentralized protocol,
And then there's the market.
yeah, anyone can use the open decentralized protocol.
Yeah.
So say some developers from Iran, and there's brilliant AI guys in University of Isfahan and Tehran, they can put their stuff on SingularityNet protocol, and just like they can put something on the internet, right? Mm-hmm. I don't control it. But if we're going to list something on the SingularityNet marketplace and put a little picture and a link to it, then if I put some Iranian AI genius's code on there, then Donald Trump can send a bunch of jackbooted thugs to my house to arrest me for doing business with Iran, right? Yeah. So I mean, we already see in some ways the value of having a decentralized protocol, because what I hope is that someone in Iran will put online an Iranian SingularityNet marketplace, right? Which you can pay in a cryptographic token, which is not owned by any country. And then if you're in like Congo or somewhere that doesn't have any problem with Iran, you can subcontract AI services that you find on that marketplace, right? Even though U.S. citizens can't by U.S. law. So right now, that's kind of a minor point. As you alluded, if regulations go in the wrong direction, it could become more of a major point. But I think it also is the case that having these workarounds to regulations in place is a defense mechanism against those regulations being put into place. And you can see that in the music industry, right? I mean, Napster just happened and BitTorrent just happened. And now most people in my kids' generation, they're baffled by the idea of paying for music, right? I mean, my dad pays for music. I mean, but that's true. Because these decentralized mechanisms happened, and then the regulations followed, right? Yeah. And the regulations would be very different if they'd been put into place before there was Napster and BitTorrent and so forth. So in the same way, we got to put AI out there in a decentralized vein and big data out there in a decentralized vein now, so that the most advanced AI in the world is fundamentally decentralized. And if that's the case, that's just the reality the regulators have to deal with. And then, as in the music case, they're going to come up with regulations that sort of work with the decentralized reality.
Beautiful.